Hello students, today we are going to take some more examples based on laws of logarithms. Okay, so first example is evaluate each of the following. First question, that is a 10 raised to log m to the base 10 plus 2 into log n to the base 10 plus 3 into log p to the base 10. Okay, so how we simplify this? 10 raised to, now here log m plus 2 into log n plus 3 into log p. So first we have to write log m plus 2 log n, that is we can write log of n square, okay, plus 3 log p, that is a log of p raised to 3, okay. Then here everywhere base is 10, okay. Then 10 raised to, now log of m plus log of n square plus log of p cube. So by first law we can write log of m into n square into p cube and to the base 10. Now if base is same, this will cancel, means log will get vanished. So what is remain? Only m into n square into p cube. Okay, so that is the answer of this question. Okay, now we will solve same way second sub question. 10 raised to log 2 plus log 3 plus log 4 up to log n. So we can, if sum of the logarithm is there, we can multiply this, means log of 2 into 3 into 4 up to n to the base 10. So again base is same. So what is the answer? Only 2 into 3 into 4 up to n. Okay, so this we can write as a n factorial. N factorial means product of first n natural numbers. Okay, so here we can add 1 also, because if we multiply by 1 there is no change in the product. So 1 into 2 into 3 up to n, then we can write it is a n factorial. Okay, understand this? N factorial means product of first n natural numbers. Okay, so 1 into 2 into 3 up to n. So this we can represent as a n factorial. Okay, this is factorial sign. Understand this? Now we will take second question. The second example is, if a greater than 0, prove that a raised to log 1 to the base a plus 2 into log 2 to the base a square plus 3 into log 3 to the base a cube plus and so on n into log n to the base a raised to n. This value we have to show that it is equal to n factorial. Okay, n factorial means product of n natural numbers. Okay, so a raised to, now log 1 to the base a I am keeping as it is, plus 2 log 2 to the base a square. Now we have one log, that is the log of n raised to p and to the base a raised to q, then it is equal to p by q. This power comes in numerator, coefficient of this, so it is comes in numerator, and power of this comes in denominator. So p by q into log n to the base a. So we have to use this property. Now this 2 we have to keep as it is. Here power of 2 is 1. Okay, so if it comes in numerator, then this 2 remains as it is. Power of base, that is a 2, so that comes in denominator. So 2 upon 2 log of 2 to the base a, plus similarly this 3 keep as it is. Here power of argument, that is a 1, so if it comes in numerator, then this 3 remain as it is, divided by power of base, that is a 3, so this comes in denominator, so 3 by 3 log of 3 to the base a, plus and so on, plus n by n, similar n by n log of n to the base a. Okay. Now this 2 by 2, 3 by 3, n by n, that is a 1. So what is remain only log 1 to the base a plus log 2 to the base a plus log 3 to the base a plus and so on log n to the base a. Okay. So a raised to, now this are in summation, so we can write log of 1 into 2 into 3 up to n, sorry, up to n to the base a. Now if base is same, okay, we have this property a raised to log of n or m to the base a, then answer is n. Okay, so a raised to log of this quantity to the base a, so we have only remain this quantity, that is a 1 plus, sorry, 1 into 2 into 3 up to n. So this means n factorial. Okay, product of n natural numbers, that is a n factorial. So this is RHS. Okay, understand this. Now we will take third example. The third example is prove that 0.16 raised to log of 1 by 3 plus 1 by 3 square plus 1 by 3 cube up to infinity to the base 2.5 is equal to 4. Okay, so first we have to find the value of this. Okay, so first I am taking 1 by 3 plus 1 by 3 square plus 1 by 3 cube up to infinity. Okay, so now if we observe this terms, then this is a geometric series. Okay, up to infinity. So we know that sum of infinite GP, that is a upon 1 minus r. So here a is the first term, that is a 1 by 3. So 1 by 3 upon 1 minus r. R, that is a 1 by 3. So a upon 1 minus r. So 1 by 3 upon 1 minus 1 by 3, that is a 2 by 3. This 3 will get cancelled. Answer is 1 by 2. Okay. So answer of this is 1 by 2. Now we have to find this log of this, answer is 1 by 2. So log of 1 by 2 to the base, or first I will write this log of 1 by 3 plus 1 by 3 square 1 by 3 cube up to infinity to the base 2.5. Now we have to simplify this. So log of this value is 1 by 2. So log of 1 by 2 to the base 2.5. Okay. Now see here, log of 1 by 2. This 2.5 I can write 5 by 2. Okay, so log of 1 by 2 to the base 5 by 2. Okay, now I am taking reciprocal of both. So this means 1 by 2 I can write 2 raised to minus 1, and 5 by 2 I can write 2 by 5 raised to minus 1. Okay, so again same property we have to use, log of n raised to p to the base a raised to q. So it is a p by q into log n to the base a. So similarly here, log of 2 raised to minus 1 to the base 2 by 5 raised to minus 1. Okay, so this power of argument becomes numerator, so minus 1 upon this minus 1 becomes as a denominator upon this minus 1 into log 2 to the base 2 by 5. Okay, so if we simplify this minus 1 will get cancelled. What is remain? Log 2 to the base 2 by 5. If we write in decimal, that is a 0.4. Okay, why we write the 0.4? Because here 0.16, that is a 0.4 square. Okay, so value of this total value is log 2 to the base 0.4. Now we have to further simplify this. Okay, so 0.16 raised to this log of 1 by 3 plus 1 by 3 square up to infinity to the base 2.5. So this becomes 0.16 raised to this value, that is a log 2 to the base 0.4. Okay, now this 0.16 we can write 0.4 square and raised to this exponent, that is a log 2 to the base 0.4. Now a raised to m raised to n, that is a raised to m. So 0.4 raised to 2 into log 2 to the base 0.4. Okay, now this coefficients become power of argument. So 0.4 raised to log of 2 square to the base 0.4. Okay, now this base and this base is same, so answer is 2 square, that is a 4. Okay, understand this. First find this value, after that find log of this. Okay, that is equal to log 2 to the base 0.4. Then simplify 0.16 raised to this value. Okay, so after simplifying all this we will get final answer is 4. Okay, understand this. Now we will take fourth example. Fourth example is evaluate each of the following. Okay, first one is 81 raised to 1 upon log 3 to the base 5 plus 27 raised to log of 36 to the base 9 plus 3 raised to 4 divided by log 9 to the base 7. Okay, now we simplify one. Suppose if you have to simplify first term, so how we simplify? 81 raised to 1 upon log 3 to the base 5. Okay, now I have to interchange this argument and base. Okay, so we have one log, that is a log of m to the base a, and if you have to change the argument and base, that is equal to 1 upon log a to the base m. Okay, so already we have now this 1 upon log of a to the base m. So if we have to change, then it is a log m to the base a. So 81 raised to, I can write log of 5 to the base 3. Okay, understand this. We have to use this law. Now 81 we can write 3 raised to 4. Okay, raised to log of 5 to the base 3. Okay, now a raised to m raised to n, so we can write a raised to 3 raised to mn. So 4 into log of 5 to the base 3. Now this coefficient becomes power of argument. So 3 raised to log of 5 raised to 4 to the base 3. Okay, now if this base and this base is equal, answer is 5 raised to 4. Okay, so first term if we simplify, we will get answer is 5 raised to 4. Similarly, we have to simplify second term and third term. So 27 raised to log of 36 to the base 9. Okay, now how we simplify this? So 27, that is 3 cube raised to log of 36. Okay, that log of 36 we can write 6 square, and 9 we can write 3 square. Okay, now we have another log, that is a log of n raised to p to the base a raised to q. Then we can write p by q into log n to the base a. So same law we have to use here. Log of 6 square to the base 3 square. So this 3 raised to 3 as it is. Log of 6 square to the base 3 square. So power of argument becomes numerator 2. Power of base becomes denominator. So upon 2 into log 6 to the base 3. Okay. So 3 raised to 3. This 2 by 2 cancel. What is remain? Log 6 to the base 3. Now this 3 we have to multiply here. A raised to m raised to n. So 3 raised to 3 into log 6 to the base 3. Now this 3 becomes power of argument. So 3 raised to log of 6 cube to the base 3. Okay. It is 3 raised to, okay. So 3 raised to log of 6 cube to the base 3. Now this base and this base is same. So answer is 6 cube. Okay. So second term, if we simplify, we will get answer is 6 cube. Similarly, third term. So what is third term? 3 raised to 4 upon log 9 to the base 7. Okay. Now 3 raised to, I can write this 4 into 1 upon log 9 to the base 7. Okay, so 3 raised to 4 into. Now again I have to use this law. Log m to the base a is equal to 1 upon log a to the base m. So already here 1 upon log 9 to the base 7. So if I have to write this value, so it becomes log of 7 to the base 9. Okay. Now 3 raised to, now this 4 it is in multiplication with this log, so it becomes power of 7. So 3 raised to log of 7 raised to 4 to the base 9. Again this 9 I can write 3 square. So 3 raised to log of 7 raised to 4 and 3 square. Okay. Again we have to use this law. Log of n raised to p to the base a raised to q, it is equal to p by q log n to the base a. So log of 7 raised to 4 to the base 3 square. So this power of argument becomes numerator. So 3 raised to, this is 4 becomes numerator. This power of base becomes denominator into log 7 to the base 3. So it is 3 raised to 4 by 2, it is 2 log 7 to the base 3. Again this 2 becomes power of 7. So 3 raised to log 7 square to the base 3. Again base is same. So answer is 7 square. Okay. Understand this? Now we have to add this. Okay. So okay, I will write here. This is the answer. 81 raised to 1 upon log 3 to the base 5. So when we evaluate this term, we will get answer is 5 raised to 4 plus when we evaluate second term, it is a 6 cube, and when we evaluate third term, it is a 7 square. So 5 raised to 4, it is a 625, 6 cube 216 and 7 square is 49. So if we add this 9 plus 6 15 plus 5 20, 2 plus 4 6 plus 1 7 plus 2 9 and 6 plus 2 8. So answer is 890. Okay. Understand this? See once again. If you not understand this example, see each step. Okay, where we use formula and how to simplify this. Okay, and if you are not means If we are not simplifying together all the terms, simplify one terms and then add it. Okay, understand this. Now we will take second example of this question. The second sub question of this question is log 27 to the base 9 minus log 9 to the base 27. Okay, now 9 and 27 both numbers we can write in power of 3. Okay, so log of 27 we can write 3 raised to 3 and 9 we can write 3 square minus log of again 9 we can write 3 square 27 3 cube. Okay, so now we have this log of n raised to p to the base a raised to q, then we can write p by q into log n to the base a. So same law we have to use for this log of 3 cube. So power of arguments become numerator, so 3, power of base become denominator 2 log 3 to the base 3. Okay, minus again same here power of argument becomes numerator, so 2 power of base becomes denominator, that is a 3, and log 3 to the base 3. So 3 by 2 log 3 to the base 3. Okay, that answer is 1 minus 2 by 3 into log 3 to the base 3, that is 1. So remain 3 by 2 minus 2 by 3. So if we make same denominator, 9 minus 4 upon 6. So it is a 5 by 6. Okay, understand this. Now we will take next question. The next example is evaluate 1 upon root 27 raised to 2 minus log 13 to the base 5 upon 2 into log 9 to the base 5 and whole bracket raised to 1 by 2. Okay, so we will simplify 1 bracket. Okay, first I am taking this value log 13 to the base 5 divided by 2 into log 9 to the base 5. Okay, so this we can write, okay, 1 by 2 into log of 13 to the base 5 upon log 9 to the base 5. Okay, now we have one law, that is a base changing theorem. If log of m to the base a, and if we have to change to the base b, then we can write like this way, log of m to the base b upon log of a to the base b. So this law we have to use here. Now we have this RHS, that is a log of 13 to the base 5 and log of 9 to the base 5. So this we can write 1 by 2 into log of m, that is a 13, so 13 to the base a, and that is a 9, so it is a 9. So 1 by 2 into log of 13 to the base 9, again 1 by 2 into log of 13, this 9 I can write 3 square. Okay, so this power of base becomes denominator, so 1 by 2 into this 2, that is 1 by 4 log of 13 to the base 3. So this is the simplification of this term. Okay, now we have to simplify this. So 1 upon root 27 raised to 2 minus, now simplification of this is 1 by 4 into, okay, or first time I will write that term, that is a log 13 to the base 5 upon log 9, 2 log 9 to the base 5. Okay, now 1 by root 27 raised to 2 minus, simplification of this is 1 by 4 log of 13 to the base 3. Okay, now 1 by root 27 raised to 2 2 minus 1 by 4 log 13 to the base 3. So we can separate like this way, 1 by root 27 raised to 2 into 1 by root 27 raised to a raised to m plus n. Then we can write a raised to m into a raised to n. So 1 by root 27 raised to this 2 into 1 by root 27 raised to minus 1 by 4 into log 30 to the base 3. Now 1 by root 27 square, that is a 1 by 27. Okay, if we have to make this is also 1 by 27, then we have to multiply by 2 to the base to the numerator and denominator. Okay, or here we have to make, we can write like this way, 1 by, if suppose a raised to m is there and we have to take a square, so we can write like this way, a raised to 2m by 2. So similarly I have to make this number as 1 by 27, so I have to multiply by 2 and divide it by 2, so it becomes 1 by 27. And if we multiply by 2, sorry, if we divide it by 2, because this numerator, that 2 we have to use here, so in denominator it is remain, that is a minus 1 by log 13 to the base 3. Okay, now next step, we have to simplify this also. Okay, yeah, right here. Okay, I am rubbing this one now. Okay, so after this, how we simplify 1 by 27. Okay, this 1 by 27 I can write 1 upon 3 raised to 3 and into 1 upon 3 raised to 3 raised to minus 1 by log of 13 to the base 3. So if we take in numerator, that is a 3 raised to minus 3 into 3 raised to this minus 3 raised to minus 3 raised to minus 1 by log of 13 to the base 3. Okay, so 3 raised to minus 3 into minus 3 into minus 1 by 8, that is a plus 3 by 8. So 3 raised to 3 by 8 log 13 to the base 3. Okay, so this is the simplification of this term. Okay, or we can further simplify 3 raised to minus 3 into 3 raised to, this become power of argument, so 3 raised to log of 13 to the 13 raised to 3 by 8 to the base 3. Now this base and this base is same, so 3 raised to minus 3, this as it is, into 3 raised to a log of 13 to the base 3. So this base and this base is same, so only remain 13 raised to 3 by 8. Okay, now final simplification, value of this we have 3 raised to minus 3 into 13 raised to 3 by 8. Okay, so 1 upon root 27 raised to 2 minus log of 13 to the base 5 upon 2 into log of 9 to the base 5 and whole bracket raised to 1 by 2. Okay, now simplification of this whole term we have, that is a 3 raised to minus 3 into 13 raised to 3 by 8 and bracket raised to this 1 by 2. So this 1 by 2 is for both terms, that is 3 raised to minus 3 raised to 1 by 2 and 13 raised to 3 by 8 raised to 1 by 2. So it is 3 raised to minus 3 by 2 into 3 raised to, sorry, 13 raised to 3 by 16. Okay, 3 by 8 into 1 by 2, that is a 3 by 16. So this is the final answer of this. Okay, or value of this is 3 raised to minus 3 by 2 into 13 raised to 3 by 16. Okay, so for more examples, solve from given worksheet.